The topic of the presentation, visualization of the structure of DCT based on the synthesized algorithm using cyclic convolution. Authors are Igor Prudsko, Yuri Bilas, Vasil Tisluk. The affiliation of the authors is Lviv Polytechnical National University. The various of efficient algorithms have been developed for computing discrete transform of Fourier class. What is defined in the matrix form, where W is a basic square matrix of discrete Fourier transform, discrete sine or cosine transform, discrete Hartley transform. These fast algorithms are used to present information data in a spectral image and are applied in information technologies for various purposes. The ISO-IEC organization have standardized these 8 types of DCT, which are widely used in the processing of digital audio and video signal. Direct DCT of type 2 is simply called DCT and can be represented by formula. The efficient computation DCT is divided into algorithms with a base of 2, a split base, a mixed base, and odd size and compound size, and an algorithm of simple factors. One of the approaches to the efficient computation of DCT uses the fast cyclic convolution. The usage of circular correlation structure provides high computing speed, low computational complexity, and low input-output bandwidth. It reduces the hardware cost. The result of the synthesis of computational algorithms needs their interpretation not only in the form of formula or flowcharts, but it also in general computational structure form. The proposed approach of fast algorithm synthesis using cyclic convolution is to arrive an efficient conversion, the basis of arbitrary size of DCT, into block cyclic structures. The block cyclic structure of basis matrix can be described by a hashing array, where hashing array consists integer elements, which are arguments of basic harmonic function. The hashing array is determined by substituting the columns of the arguments of basis harmonic function of DCT-based matrix. The properties of periodicity, symmetry, and asymmetry of the basis function lead to the representation of smaller values of arguments of the basis. The simplified matrix or arguments of DCT is complemented the matrix of cosine sine. For indexing the base matrix of hashing array of rows and hashing array of columns, because the different expression of columns and rows indices include the arguments of basic function. For the synthesis of fast algorithms, it is necessary to analyze the structure of the obtained block cyclic matrix in order to determine identical block placed horizontally and vertical relative to each other. This reduces the number of computation of cyclic convolution. On the example of the synthesis of fast DCT algorithms for size 27, the hashing array contains the following elements: hashing array row, hashing array column. As a result of the indexing, the block cyclic structure of arguments of DCT is presented on the feature. As a result of the analysis of the block cyclic structure of base metrics, we obtain the TXT file describing the convolution in the form on example of DCT for size 27. This data text file contains the minimum number of cyclic convolution. Input data must be previously element-wise combined. The structure rendering software implementation of fast cosine transform based on convolvers uses TypeScript programming language framework. Phaser 3 was chosen as the visualization tool. The rendering program for processing the description text file of fast algorithm uses modules: tokenizer, parser, optimizer, visualizer. The visualizer module provides imaginary of structural scheme of VCT. For this, a simple linear sequence of steps is performed. Interaction with the system is carried out through the user interface, in which settings are made to display the structural scheme of VCT. As a result, we get a display of the system on screen, and to download image into PNG files that will contain the structural scheme of VCT or part of it. The image of computational structure of VCT for size 27 uses cyclic convolution is presented. The unit of cyclic convolution 9.3. The unit element-wise combined input data and combined results of cyclic convolution. The scientific novelty of obtaining results lies in the implementation, the visualization of the computational structure of discrete cosine transform on the basis of created description of the synthesized algorithm, which include a multi-level set of cyclic convolutions. The practical significance of the work lies in the fact that the obtained results of visualization of computer structural scheme of the VCT for specific size of transform is important for the system engineering state of designing a fast VCT based on cyclic convolution, because clearly reflected the general interaction of its parts on algorithmic level. Prospects for further research as a development and implementation CAD system for designs the computational structure of DCT using a low complexity convolutional formulation. Thank you for attention.